So today we are going to solve some problems based upon the free body diagrams, right? So let us discuss a few small topics. Okay, so let's discuss this topic called as Atwood's machine. Now what is an Atwood's machine? Suppose you have this pulley. Okay, it's connected to this rigid support and you can rotate that pulley. Okay, and this pulley is massless. The pulley has no mass, and there is a string which passes over the pulley, and you connect these two masses m1 and m2, okay, these two weights to the string. Then now what happens? Now what would be the acceleration of this system? So this system is known as an Atwood's machine. Okay, this is just name. Then now suppose you have this mass m1, this mass is m2. So if you just think about m1, its weight is acting downwards. Okay, that's m1 into g. And suppose tension in the string is upwards, right? Tension in the string is upwards. So tension is T1. Okay. Then this mass is m2. Its weight is acting downwards. The weight is m2 times g, and tension is upwards. Tension is suppose T2. Now since this is the same string, so you can say that tension in the string will be equal. Okay, tension in the string will be equal, right, for the same string. And then if m2 is greater than m1, then our common sense says that the system will accelerate like this. So m2 will go down with some acceleration, m1 will go up. So let's suppose m2 is greater than m1. So if m2 accelerates downwards, m1 must accelerate upwards. So then we can write down the equation of forces for m1 and m2. So what will be the net force acting on m1? It is just, if it is moving upwards, we can say that net force is upwards. Okay, so then it's equal to T minus m1 into g. Okay, if we talk about m2, the net force would be downwards because it is moving downwards. So net force is downwards. What is the downward force? m2 into g. What is the upward force? T2. So net downward force must be m2g minus T2. And because acceleration is a, so you can say net force is mass into acceleration, that is m2 into a. m2 multiplied by a is equal to m2 multiplied by g, the net downward force, minus net upward force is tension. Okay, so m2g minus t. So suppose this is your equation 1. Then m1 moves upwards. Okay, m1 moves upwards with some acceleration a. So tension must be greater compared to its weight, right? So tension is T1. So net force is mass multiplied by acceleration, m1 into a. Tension is T1. Okay, actually T1 is equal to T2, that's T. So tension is T. So you have T minus m1 into g, right? Upward force minus downward force. So that is equation 2. If you add up the two equations, you get what? A you can take common. So it is a times m1 plus m2 on left hand side. And on right hand side, what do you have? This t and t will get cancelled out. m2 times g minus m1 times g. So again, you can take g common on right hand side. So what will remain? m2 minus m1. Then you can find out acceleration very easily. Just move that m1 plus m2 on another side. So you get acceleration is equal to what? m2 minus m1 divided by m2 plus m1 multiplied by g. Okay. So now if your assumption is correct that if m2 is greater than m1, then acceleration would be positive. If m2 is less than m1, then acceleration would be negative. So we just have to remember this formula. A is equal to m2 minus m1 divided by m2 plus m1 multiplied by g. Okay, very simple formula, right? Then let's take another problem. Okay, let's talk about another problem. So there is a man standing in a lift and there is a weighing scale, weighing machine inside the lift. Okay, so man is standing above the weighing scale. So the lift is moving or lift is steady, whatever, but man sees his weight. Okay, right, on the weighing scale. So m is suppose mass of the man, woman. m2 is mass of the lift. Okay, and then now if lift is steady, what can you say here? So this is the lift, it's connected to this rigid support by means of the string. Okay, so if lift is steady, then what would be tension in this cable or string which is supporting the lift? If lift is steady means the net upward force is equal to net downward force. So mass of man is m and mass of lift is m2. What will be total mass? Total mass is just equal to m plus m2, right? Or let's say it is m1. So m1 plus m2 is the total mass. Okay, right? So then what would be tension? Tension is just supporting the weight because it's not moving upwards, it's not moving downwards, there is no acceleration, and therefore tension is just equal to what? Total weight. So that is m times g. So m1 plus m2 multiplied by g. Okay, then now suppose it moves downwards with constant velocity v. Okay, still t will be equal to mg because still there is no acceleration, so forces are balanced, right? According to Newton's first law, the bodies, they remain steady or they keep on moving with constant velocity till the time there is no net external force. So if it moves downwards with some velocity, constant velocity, then still tension is equal to mg. So this tension in the cable balances what? Total weight of the man and the lift, right? Again, if it accelerates upwards with some velocity, still the tension is equal to mg. Okay, so in all those three cases, steady, moving upwards with some velocity, constant velocity, moving downwards with some constant velocity, tension is just equal to mg. So that's simple, right? So then let's consider next two cases. If it accelerates upwards with acceleration a or downwards with some acceleration a, then what would be the tension? Okay, so lift accelerates upwards, then what will happen? So the total mass is m, so you can say the net force is equal to what? M multiplied by a. So m multiplied by a is equal to what? T minus mg, because tension would be greater. Since acceleration is upwards, upwards force must be greater than downwards force. So tension is greater compared to mg, right? So mass times acceleration is equal to what? T minus mg. And therefore you can take mg on this side, so you get T is equal to what? M into g plus a. Okay, so tension would be greater if the system is accelerating upwards, right? Then if it is accelerating downwards, means downwards force is greater. So total force m into a is equal to what? Mg, the downward force, minus upward force, tension, mg minus t. And therefore tension would be equal to what? Just take tension on this side, ma on that side. Tension is equal to m into g minus a. This is clear, everyone? Good. Then now this is about the tension in this supporting cable. Now let's talk about the weight experienced by the man. Okay, weight experienced by the man in different cases. So if lift is steady or moving with constant velocity, so he is standing on the weighing scale. Okay, so what is the weight experienced by the man? Weight experienced by the man is just equal to the normal reaction. Weight experienced by the man is just equal to what? Normal reaction exerted by that weighing scale. Okay, so normal reaction is upwards, his weight is downwards. Okay, so then what you can say is the normal reaction balances the gravitational force, okay, mg, and when it is steady or moving with constant velocity, because there is no acceleration. So these two forces are balanced, and therefore n is equal to mg, right? Therefore n is equal to mg. This thing is clear? Yes, no? Okay, then if it is accelerating upwards, that means the normal reaction, the upward force must be greater compared to mg, and that's why he will feel his weight has increased, right? So see how? So since lift is accelerating upwards with acceleration a, normal reaction is greater than mg, downward force, and therefore net force is mass multiplied by acceleration, ma. Okay, it's equal to normal reaction minus mg, n minus mg, and move mg on other side, so you get normal reaction is equal to m multiplied by g plus a. Okay, right, if you move mg on other side, you can take m common, so normal reaction is m multiplied by g plus a. Okay, so if lift moves upwards with acceleration a, the person feels that his weight has increased. Okay, if lift moves down with acceleration a, the person will feel his weight has decreased. So in this case, mg is greater compared to normal reaction because the net force is downwards, the acceleration is downwards, and the net force is ma. Okay, mass into acceleration, it's equal to the downward force mg minus the upward force n, normal reaction. So n is equal to m into g minus a. Right, just move n on this side, ma on that side, so you get n is equal to m into g minus a. Okay, and suppose somebody cuts the cable of that lift. Okay, so lift falls down with acceleration equal to g, then how much is the acceleration? Acceleration is g. Then what would be the normal reaction? Normal reaction is 0. Okay, because put a equal to g, so g and g gets cancelled out, so man will feel weightless. Okay, the man will feel weightless. So this thing is clear. Okay, so suppose somebody jumps from top of a tower, okay, very high tower, so till the time he reaches the ground, he will feel what? Weightless, neglecting the air friction. Okay, this thing is clear, everyone? Okay, good. Then let's talk about a force called as spring force. What is this? So suppose we have this mass, it's connected to the spring, and the spring is connected to the rigid support, and mass is kept on a table, right? Now suppose you pull on that mass, so what will happen? The mass will pull on the string. Okay, it will pull the spring, not string, spring, and then there will be some elongation in the spring. So if there is some elongation in the spring, what will happen next? If you release the mass, there is an internal restoring force generated in the spring which acts in the opposite direction of displacement. So if there is elongation, then the spring will try to restore it back to its original length. Okay, so there will be internal restoring force. Let's say elongation is towards right, the restoring force will be towards left. Okay, and because of that, what will happen? The mass will be pulled towards left by the spring force when you release the external force, right? So then what you can do here is, there is a law called as Hooke's law, which gives us the relation between the spring force, okay, the internal restoring force generated in the spring, and the displacement, right? So Fs is the restoring force in the spring, and suppose x is the displacement, then the Hooke's law says that this internal restoring force is directly proportional to the displacement, but it acts in the opposite direction as that of displacement. Okay, so that's simple. When you elongate the spring, it wants to restore itself. Okay, so then if displacement is let's say towards right, that means you are increasing the length, so force will be towards left. Okay, it wants to decrease the length. Okay, actually it wants to restore the length, right? So that's why the spring force acts in the opposite direction of the displacement. Okay, and then if you remove this proportionality sign, put an equality sign, a constant will enter, and this constant k is known as a spring constant, right? This thing is clear, everyone? Yes, no? Okay, so this is the spring force. So there are some problems based upon spring force also. And then now suppose you take some mass and this is the spring balance, okay, or suppose this is just some spring, right? So when spring is not elongated, then suppose its original length is x. Now if you connect some mass to it, if you connect some weight to it, what will happen? The weight acts downwards, and that's why the spring will get elongated, okay. So this thing will keep on happening till the time the internal restoring force balances the weight. So at the equilibrium, when the mass is not accelerating upwards or it is not accelerating downwards, the spring force and this weight must be balanced. And for that, suppose delta x is the elongation in the spring. So spring force is equal to mg. So how can you write the spring force? So k is equal to, Fs is equal to k times delta x. Okay, Fs is equal to what? K times delta x, and that's equal to mg. So if you want to find out elongation, just move the k on other side. So you get delta x is equal to mg divided by k, right? Very, very simple. So this is the elongation in the spring. Okay, this is clear? Yes, no? Okay. So then let's solve some problems based upon these things. So the problem on Atwood's machine. Two masses as shown in the figure are suspended from the massless pulley. The acceleration of the system when masses are left free is. So one is 10 gram, another one is 5 gram. So this is m1, let's say this is m2. So tell me what's the acceleration? Acceleration is equal to m2 minus m1 divided by m2 plus m1 multiplied by g. Okay, so that is 10 minus 5 divided by 10 plus 5. Yeah, it's option B. Let's check. Multiplied by g. 10 minus 5 is 5. 5 divided by 15. So it is 1 by 3. Right. So g by 3 is the answer. So this one is very simple, right? Let's see next one. Two bodies of mass 4 kg and 6 kg are tied to the ends of a massless string. So similar one. The string passes over a pulley which is frictionless. It is frictionless and also massless. That is, we consider that the pulley is frictionless and massless. Okay. The acceleration of the system in terms of acceleration due to gravity g is. So again similar to last one, option C, g by 5. Okay, let's check. So it is m2 minus m1. Acceleration is m2 minus m1 divided by m2 plus m1 multiplied by g. Now you don't even have to write down this formula, right? Yeah, g by 5. Okay, so m2 is 6. 6 minus 4 divided by 6 plus 4. Correct. So 2 by 10 means 1 by 5. So the acceleration is just equal to g by 5. Okay, so this is very old problem, but still they keep on asking it sometimes, right? So this is from NEET 2020, quite a recent one. Okay, but they ask it sometimes, so we need to remember this formula. All right, let's see next one. A person of mass 60 kg is inside a lift of mass 940 kg and presses the button on the control panel. So there is some control panel inside the lift. The lift starts moving upwards with acceleration 1 meter per second square. If g is equal to 10 meters per second square, the tension in the supporting cable is. Tell me, what is total mass? Total mass is m1 plus m2, mass of the man plus mass of the lift. Okay. Now if there are n people inside the lift, then you will take collective mass of them. Okay. So that is 60 plus 940. So it is 1000 kgs. This is total mass. So what is the tension? If lift accelerates upwards, the tension is just equal to what? Total mass multiplied by g plus a. Okay, we just saw this. So it is m is equal to 1000 multiplied by g plus a. So 10 plus 1. So it is 11 times 1000 means 11,000. 11,000 Newton. This is the answer. Okay, very simple. Yes, no? Okay. Does anybody have any problem in this? Okay, good. Let's see next one. The mass of a lift is 2000 kgs. When the tension in the supporting cable is 28,000 Newton, then its acceleration is. Tension is 28,000 Newton, then its acceleration is. Then there are some options with upwards acceleration, some with downwards acceleration. So you need to consider something. Okay, so what we can do is we can quickly find out its weight. So weight is mass times 10, 20,000. So if tension is greater than the weight, that means acceleration must be upwards, right? Acceleration must be upwards. So if lift accelerates upwards, you have this formula, T is equal to what? M into G plus A. Now here there is no need to think. Okay, just write down any formula. T is equal to M into G plus A or M into G minus A. So this is for when lift accelerates upwards. Now you don't need to think whether it's accelerating upwards or downwards, right? While solving problems you can think, but in exam just write down this formula. So if your assumption is correct, then the acceleration will come positive. If it's incorrect, the acceleration will come negative. Okay, so just write down T is equal to M into G plus A. So T is 28,000. Okay, just calculate the acceleration. How much is mass? 2000. Okay, G is 10, 10 plus A. So just move that 2000 on other side. 28,000 divided by 2000 is 14. So 14 is equal to 10 plus A. Okay, that means A is equal to 14 minus 10. So 4 meters per second square. So the formula you wrote is for upwards acceleration and it comes out to be positive. That means acceleration is upwards. Okay, so 4 meters per second square upwards, right? So this is the answer. Okay, so what I am saying is we can think this way that, oh, the mass is 2000 kgs, then acceleration due to gravity is 10, so weight is 20,000, then the tension is 28,000. Because tension is greater than the weight, then what will happen? The lift will be accelerating upwards. Okay, because for upwards acceleration you need tension to be greater compared to the weight, right? Okay, so but then if you want to save time, just write down T is equal to M into G plus A. Okay, whether it's accelerating upwards, downwards, we'll check that. So T is equal to M into G plus A. Just solve for the acceleration. If acceleration is correct, then the formula you used is correct. That means lift is accelerating upwards, otherwise it is accelerating downwards. Clear? Yes, no? Okay, if you use T is equal to M into G plus A, acceleration comes out to be positive. That means it is accelerating upwards, otherwise it is accelerating downwards. Very simple. Okay, good. Let's see next one. A monkey is descending from a branch of a tree with constant acceleration. Now there is a monkey which is descending from branch of a tree, and we'll consider the branch to be vertical. Okay, it's descending, so we'll consider the branch to be vertical. If breaking strength of branch is 75% the weight of the monkey, the minimum acceleration with which monkey can slide down without breaking the branch is. So monkey must, so just suppose this is a monkey, let's suppose this is a monkey, okay. Now he's descending down with some acceleration, so descending down with some acceleration a. So there would be some tension in this branch, right, because it has to support his weight. So tension in the branch is suppose in upwards direction. So what's happening? Tension is upwards and his weight is acting downwards. His weight is acting downwards. Mg is the weight. Okay. And breaking tension or breaking strength is 75% of the weight. This thing is given. The breaking strength is 75% of the weight. Right. So then what must be his acceleration downwards? So for downwards acceleration, you can say mass times acceleration is equal to mg minus tension or breaking strength, you can say. Okay, it's the tension only, tension in the branch. Okay, then what would be t? T is just equal to m into g minus a. Okay, so for descending motion, you can just write down t is equal to m into g minus a always. Okay, for the lift, for the monkey who is sliding down from the branch of a tree, the same formula is applicable, right? So then what should be the acceleration? This is question, no? So what is tension? Tension is just equal to 3/4 of his weight, 3/4 of mg. Okay, that's equal to mg minus ma. You can cancel out m everywhere. Okay, so then move this ma on this side. So ma is equal to mg minus 3/4 of mg. Okay, so this thing is 1/4 of mg. Cancels out, so you have a is equal to g/4. So this is the answer, option C. Right, this thing is clear. Okay, everyone. All right, good. So let's see next one. A monkey of mass 20 kg is holding a vertical rope. Okay, so branch is changed to a rope, vertical rope. So this is better approximation, right? Because branches are not always vertical. Okay, the rope will not break when the mass of 25 kg is suspended from it, but will break if the mass exceeds 25 kg. So what is breaking strength or breaking tension? It is 25 kg weight, right? What is the maximum acceleration with which monkey can climb up along the rope? So the same problem. Now monkey is moving up the rope. So again we have this monkey. You don't need to draw this in exam. You can, by the time you can just tell me the formula. Monkey is accelerating upwards. Tell me. There will be some tension in this rope. T is the tension. Okay, his weight will be acting downwards. Weight is always acting downwards. So he is moving up with some acceleration. Then what's the tension? T is equal to m into g plus a. Right? We can just write down this formula, but if we don't remember, we can always say that he is accelerating upwards. So ma is equal to what? Upward force minus downward force, T minus mg. And very quickly we can find out that T is equal to what? Ma plus mg, or you can take m common. So T is equal to m into g plus a, m multiplied by g plus a. So this is very, very simple, right? But it's better if we remember the formula. Accelerating upwards means tension is m into g plus a. So put the values. So tension is 25 kg weight, 25 multiplied by g, and how much is mass? Mass is 20, right? 20 times g plus a. So then 25 divided by 20, okay, or better way is this is 20 times g, this is 250, and this is 200 plus 20a. I have put g equals to 10. So move this thing on other side. So that's 250 minus 200 is 50. 50 is equal to 20a. Okay, 20a is equal to 50, means a is equal to 50 by 2, 50 by 20. So that's 2.5 meters per second squared. Okay, this is the answer. That's very simple. Right? Okay, let's see next one. A mass of 1 kg is suspended by a thread. It is lifted up with acceleration 4.9 meters per second squared, lowered with acceleration 4.9 meters per second squared. The ratio of the tensions is, tell me, lifted up with some acceleration. Okay, so in that case, suppose tension is T1. So when it is lifted up with acceleration, the tension is m into g plus a. Okay, lowered down with some acceleration, so suppose tension is T2, then it is m into g minus a, and we just want ratio of the two, so T1 by T2. Okay, so that is m times g plus a divided by m times g minus a. M gets cancelled out. G plus a divided by g minus a, g plus a divided by g minus a. So that is, what is g? 9.8. 9.8 plus 4.9 divided by 9.8 minus 4.9. Okay, so 9.8 is twice of 4.9, so it is 2 times of 4.9. Okay, 2 times of 4.9 plus 4.9 means 3 times of 4.9, and in denominator you have 2 minus 1 times of 4.9, so that is 4.9 only. So that thing gets cancelled, so it is 3:1. Okay, so answer is 3:1, right? So this one is clear. Okay, similar kind of problems. So these problems are repeated many times. Okay, so I have taken few of them, but there are more, right? Okay, let's see next one. 3 blocks with masses m, 2m and 3m are connected by strings as shown in the figure. So like this. After an upward force F is applied on mass on block M, to apply some upward force F, the masses move upward with constant speed v. So masses move upward with constant speed v. What is the net force on block of mass 2m? So g is the acceleration due to gravity. What is the net force on this one? Okay, tell me. How do we solve this? Anyone? Net force is 0, isn't it? You don't even need to think about this. The system is moving with constant velocity v. means the net force acting on the system is 0. Yes, no, right? So system is moving means every mass is moving with the same velocity. Every mass is moving with same velocity means the net force is 0 acting on every mass, each and every mass. Okay, so this is the answer, option C, the net force is 0. Alright, let's see next one. Two blocks A and B of mass 3m and m respectively are connected by a massless and inextensible string. Okay, two masses are connected with a string. The whole system is suspended by a massless spring as shown. So this whole system means mass A and mass B. Okay, they are connected by means of a spring. The magnitudes of acceleration of A and B immediately after the string is cut. When you cut the string, okay, not the spring, you cut the string, are respectively. Tell me. The string is cut. Okay, so let's draw the free body diagram. First, let's draw free body diagram of B first. Okay, before the string is cut. So for B, tension is there, which is acting upwards. Okay, it's connected to this string, no? So there is an upwards tension and its weight is acting downwards. And initially there is no acceleration. That means the tension is just equal to m times g, right? This is for B. Then for A, what will happen? So this is A, the spring force acts upwards. So let's say this is Fs and tension acts downwards. Okay, and tension is equal to mg and its weight also acts downwards. So its weight is equal to what? Its mass is 3m, so weight is equal to 3m times g. So you can say the tension plus this weight is equal to the spring force, right? The spring force Fs is equal to tension plus mg. So that's equal to, tension was mg plus, oh no, not mg, this is 3mg, right? This is 3mg. Okay, so that's 3mg because mass of this one is 3m. So T plus 3mg means mg plus 3mg, so it is 4mg. Okay, so now what's the question? The magnitudes of acceleration of A and B when immediately after the string is cut. Now you cut the string, okay, cut the string, then what would be the accelerations? So when you cut the string, what will happen? What will happen to this B? Option A. Okay, let's check. When string is cut, B will just accelerate downwards. Okay, because the upward force is 0 on B and therefore the net force is mg, so which is equal to mass times acceleration, right? So acceleration is just equal to g. Okay, then what about this one? So for this one, now again the string is cut, so tension would be equal to 0, but then now the system will come to equilibrium, but it will take some time. Okay, the net force upwards is Fs, so the spring doesn't know that string is cut, right? So the spring force remains the same for time being. Okay, spring force remains the same. So spring force is acting upwards and this one is acting downwards. because spring is displaced. No, so spring force is equal to what? It is equal to K multiplied by the displacement. Okay, spring force is equal to K multiplied by displacement, right? So when you cut the string, the displacement in the spring doesn't change immediately, and therefore the spring force will remain same. Okay, so Fs is equal to Fs is greater compared to that of this thing, because Fs is equal to 4 mg, and therefore there is net force upwards. How much is the net force? Net force is mass times acceleration. It is Fs minus mg, right? And that is 4 mg minus mg means it's mg. Okay, but its mass is 3m. Its mass is not m. Mass is 3m, right? Mass of A is 3m. Okay, so it is 3m times acceleration. 3m times acceleration. 3m times acceleration is what? It's equal to mg. Mm cancels out. Okay, and therefore you get acceleration is equal to what? It's equal to g by 3. Acceleration, this is my g, okay, g by 3, right? So Bhanu was correct. So acceleration is g by 3. This thing is clear? Right? Yes, no? Everyone? Right? Okay, let's see next one. Two masses 10 kg and 20 kg respectively are connected by a massless spring as shown in the figure. The force of 200 Newton acts on the 20 kg mass at the instant shown in the figure. Okay, at the instant shown in figure, it should be, right, they have written is figure. The 10 kg mass has acceleration of 12 meters per second squared. So this is 10 kg mass and it has acceleration of 12 meters per second squared. The value of acceleration of 20 kg mass is, this is the question. Okay, so again we need to draw the free body diagrams of them independently. So this is 10 kg mass. What's the force acting on it? There is only one force, that's the spring force. Okay, so that is F, suppose, not suppose, it's given, it's F, and its acceleration is, how much is acceleration? 12 meters per second squared. So here you can say that F is equal to mass times acceleration, and that is just equal to what? Mass is 10, acceleration is 12, that's given. So therefore it is 120 Newton. So you got F. Okay, then for the second mass, this is the second mass. For this one, this F is acting towards left and you are exerting a force of 200 Newton, right? And F is acting in this direction. So what would be the net force? Net force will be in this direction, which is mass times acceleration, that is 200 minus F, or it's 200 minus 120, so that is equal to 80, and mass is 20 kg, right? So 20 times A is 80, and therefore what's A? A is equal to 80 by 20, so 4 meters per second squared. So that is the answer. It's option A. This one is clear? Yes, no? If there is some confusion, you can ask me. Yes, everyone? Okay, no problem. So see, you have these two masses. Okay, so let's just keep the free body diagrams. So see, this is 10 kg mass and you have the spring. Okay, so the spring is elongated, therefore what will happen? The restoring force in the spring, it's not given that spring is elongated, I'm telling that from this diagram, because the spring force, it's given, its direction is given. So for this mass it acts like this, for this one it acts like this. So what's the result of this? It will try to compress the spring, right? So then see, spring force on this mass is acting in this direction and there is only that force. Okay, there is nothing else. I mean, there is weight and the normal reaction, but they will cancel out, right? The weight and normal reaction will cancel out. Okay, so acceleration is 12 meters per second squared, that is given. Okay, acceleration of 10 kg mass is 12 meters per second squared. So it is because of the spring force only. The spring force is just equal to what? Mass into acceleration, right? What is the mass? Mass is 10. 10 multiplied by acceleration is 12. So from that you find out this one, it's 120. So spring force is 120 Newton, right? What about the other mass? So on other mass, the spring force is acting like this, okay, towards left, and there is another force of 200 Newton acting towards right. So that is 200 Newton, and spring force you just calculated, that is 120 Newton. So this force is greater, therefore you have mass times acceleration acting in this direction. So m into a, or you can say this was m1, this is m2, okay, just to avoid confusion, this is m2. So m2 times a is equal to what? This 200 Newton minus the spring force which is acting towards left, okay, and then just put the values. 200 minus spring force will be equal, because it's the same spring, right? So this thing is 80, m2 times a is 80, m2 is 20, this is 20 times a, that's 80, and therefore a is equal to 4. Okay, this thing is clear? Yeah, welcome. Everyone, is it clear? Okay, good. So these are very, very simple problems. Now, how can you increase the complexity of this one? So instead of 2 masses, they can give you 3 masses. They can give you 4 masses. Okay, 1, 2, 3, 4, right? But then solving for that will be lengthy. Okay, let's see next one. The coefficient of static friction mu s between the block of mass 2 kg. So this is the block of mass 2 kg, and the table as shown in the figure is 0.2. So this is the table. What would be the maximum mass value of block B? So what should be the mass of block B? Let's say it is m2, this one is m1, right? So that the two blocks do not move. These two blocks don't move. This is given. The string and the pulley are assumed to be smooth and massless. Okay, the string, not the spring. String and the pulley are massless and smooth, means there is no friction, right? So now let's draw free body diagrams of these two masses. So what I am doing is I am just redrawing the same diagram a little bit bigger, nothing else. Okay, so you have this mass, and then there is another mass, there is this pulley, right? So now let's think about this one. Both the masses, they don't move at all. So now for this mass, second mass, the tension acts upwards, okay, and tension acts upwards, and its weight acts downwards. Weight is m2 times g, and it doesn't move, means what? The tension balances the weight, right? Tension balances the weight. So what can you say? T is just equal to m2 multiplied by g. This thing is clear. Okay, now think of this one. What are the forces acting on this one? There is the weight acting downwards, but it is balanced by the normal reaction. This is m1g, normal reaction is n, so n is equal to m1g, so no need to think about that. But then the string is pulling it, or actually this weight is pulling this system in downwards direction, right? So the tension will act in this direction, tension is T, but then there is some friction between the table and this block. Okay, table and the block surface, there is some tension between them, sorry, there is some friction between them, not tension, friction between them. So because of that, what will happen? It's given that it doesn't move, so friction is Fs, so that means that Fs is just equal to T. Okay, so Fs just equal to T. But what is Fs? Or you can write this as T is equal to Fs. Fs is mu s multiplied by the normal reaction. What is the normal reaction? Normal reaction is just equal to its weight. Okay, because the floor is horizontal. So normal reaction is equal to weight. So mu s multiplied by m1g. So this is, you can say, equation 1. This is equation 2. Equation 1 says that T is equal to m2g. Equation 2 says that T is equal to mu s multiplied by m1g. Means mu s multiplied by m1g is equal to m2g. And what do you want? You want the maximum value, okay, maximum mass value of block B. So you don't know what is mass of the block B, that you want to find out. So just move G on other side. You can just say that m2 is equal to mu1 times m1g. No need, right? G gets cancelled out, no, sorry, G gets cancelled out. So you have m2 is equal to mu1 times m1. Okay, so just put the values. Mu1 times m1, or not mu1, it's mu s, no, I wrote mu1, mu s times m1. Okay, so I wrote suffix for that too. Okay, so this thing is clear. Mu s times m1, and that is equal to, what's mu s? It's 0.2, 0.2 multiplied by m1. What's m1? m1 is 2, so 0.4. Okay, so 0.4 kg is the answer, right? This thing is clear? Yes, no? Okay, so that's very simple, right? So here now you can just think of the string as mode of transfer of force. Okay, just hear me out. You can think of this string as the mode of transfer of the force. So what you can say is, the string is there, and if there is no acceleration, means, see, if you think about the system, there is one force acting this way and other force is acting this way, right? So because of this force, the other force, this force, okay, it will be acting like this. Okay, if there is no acceleration at all, that means this force and this force, they must be equal, right? The system is connected by means of a string. So if it accelerates, this mass will accelerate like this, but since the system is like this, it's connected by means of the string, this mass will accelerate downwards, but the acceleration will be equal. Okay, so for this kind of system, what you can do is, you can directly write down a formula. So let me explain. So we have this system. So what's the collective mass? It's m1 plus m2, right? So let's assume that the system is accelerating like this. Let's assume that the system is accelerating like this. It's not, but let's say. So I can say the total mass is m, which is equal to m1 plus m2. So m times a is equal to, it's equal to what? Net force in this direction minus the net force in other direction. Okay, so that is the friction, right? So net force in this direction, that's m2g, minus net force in other direction, it's the frictional force. That's it. Okay, so that is m2g minus, what is friction? It's mu multiplied by m1g. Okay, that too we can directly write down, no need to write n and the normal reaction and the weight, etc., because this is horizontal surface. Okay, friction is just equal to mu multiplied by n, and n is equal to m times g, right? So you can directly write down this formula, and then if acceleration is zero means what? You have m2 times g is equal to mu times m1g, then gg gets cancelled out and you get the answer. Okay, so this thing is clear. Right? So that's very simple. Okay, so now in this case, because the system is not accelerating, so you may not feel that this is serving you any better, okay, or this is helping you, but there might be some problems. This one we have solved. Okay, let's see this one. A system consists of three masses. Okay, now there are three masses, m1, m2 and m3, connected by a string passing over a pulley P. The mass m1 hangs freely and m2 and m3 are on the rough horizontal table. The pulley is frictionless and of negligible mass. The downward acceleration of mass m1 is. Tell me. Now what we'll do is, let's consider this thing as a system, this whole thing as a system. Okay, so this m1 is pulling the system down, right, and there would be some tension in the string. So tension, there would be some tension in the string. So what does the tension do? It just transfers the forces, right? So you have m1 times g acting like this, which is pulling the system down. That means it's pulling these masses towards left. Okay, it's pulling these masses towards left, right? What you can say is the whole system moves with some acceleration like this. Okay, so when whole system accelerates, the m1 will go down with acceleration a, these two will accelerate towards left, and therefore you can say that mass times acceleration. Okay, what is mass? The mass of the system, m1 plus m2 plus m3. Okay, so mass times acceleration is just equal to the force which is in direction of acceleration. So that is this force. Okay, it's the m1 which is pulling the system down. That means it's resulting in acceleration of the system. Okay, so that is m1 times g minus what? The frictional force. Okay, what is opposing the acceleration? The frictional force. Frictional force is acting in this direction, right? So therefore it's equal to m1g minus frictional forces mu s multiplied by normal reaction. What is the normal reaction here? So it is m2 plus m3 times g. right? So it is m1g minus, let's write it here, so mass times acceleration, mass times total mass times acceleration is equal to m1 times g minus mu s multiplied by m1 plus, not m1, m2 plus m3 multiplied by g. Okay, is this thing clear, everyone? Everyone, right? And then what's given? Assume that m1, m2 and m3 are equal to m. So just replace this thing, okay, m1, m2, m3 by m, small m. So this total mass is equal to what? 3m then, because it's m1 plus m2 plus m3. So 3m times a, you have 3m multiplied by a is equal to m1 times g, that is m times g, minus how much is mu s? Mu s is given, mu s is not given. Okay, it's mu only, right? All of the options are in terms of mu, right? So it is mu multiplied by m2 plus m3 is 2m multiplied by g. So then m will get cancelled out everywhere, and we can move that 3 on other side. So we get acceleration a is equal to g minus 2, g also we can take common, so 1 minus 2 times mu into g. Okay, this is 3a, therefore a is equal to what? Write it here, a is equal to 1 minus 2 mu divided by 3 times g. So this is the answer, 1 minus 2 mu divided by 3. So it is option C. Okay, is this thing clear? Right. Now see, in this one it certainly helped when we wrote this formula directly. Okay, if we had written the free body diagram for this one, okay, if we had drawn the free body diagram for this one, then this one and this one, it would take a lot of time, right? So this method is clear. All right, good. Let's see next one. In the given figure, the pulley is assumed massless and frictionless. If the frictional force on the object of mass m is F, then its acceleration in terms of force capital F will be equal to. Okay, so here you have this pulley, right? So there is some force F acting in this direction, and there will be tension in the string which is passing over the pulley. So tension is T and T, both in same direction, right? So therefore now see, this is free body diagram of pulley. So pulley is massless. Okay, the system is accelerating, there is some acceleration A, but pulley is massless, means you can say the mass times acceleration, it's mass multiplied by acceleration. Let's say mass of pulley times acceleration is equal to what? F multiplied by, sorry, F minus 2t. Okay, F minus 2t. Okay, t plus t is 2t. So what do you get? If mass of pulley is 0, so this term becomes 0, and therefore you get F is just equal to 2 times t. Okay, F is just equal to 2 times t because mass of the pulley is 0. Okay, since mass of pulley is equal to 0, so this term becomes 0 and F is just equal to 2 times t, or you get t is equal to F by 2, and then you are pulling this mass, okay, with the string. So there is some tension in the string which is equal to F by 2, and therefore what would be the acceleration? So it's given that there is frictional force also, it's acting in opposite direction, that is F. So therefore you have net force. Okay, net force is mass times acceleration is equal to tension minus F. Okay, tension minus the frictional force. And what is tension? So tension is equal to capital F by 2, okay, minus small f you have. So this is m times A. This is m times A, and therefore you have A is equal to F by 2 minus F divided by m. Right, so that's the answer. It's option B, right? F by 2 minus F divided by m. So this thing is clear. Okay, everyone. Right, is there any doubt? Okay, once again, see here you have this pulley, the second part, this one. Okay, so you have this mass m, and for this mass tension in the there is the string connected to this mass, so tension in the string is T, and it's given that the frictional force on the object of mass is F. So frictional force is towards left, right, tension is towards right. Okay, and you found that tension is equal to capital F by 2. So its mass, this mass times acceleration, okay, suppose it is accelerating towards right, so it will be equal to this tension in the string minus small f, okay, the frictional force, and therefore mass times acceleration is tension is equal to F by 2, capital F by 2, okay, minus F, and therefore what would be acceleration? Just move m on other side. That is simple, no? Okay, now we'll solve some problems based on the inertial frame of reference and non-inertial frame of reference. Okay, so what we'll do is we'll solve the same problem in the inertial frame of reference and the non-inertial frame of reference. Okay, and you will see that the answers will be equal. So now whether to use the inertial or non-inertial, it's up to you. Okay, and it will consume same time also. So let's see this one. A block of mass m is in contact with the cart C as shown in the figure. The coefficient of static friction between the block and the cart is mu. So this block and the cart, the coefficient of static friction between them is mu. The acceleration alpha of the cart that will prevent the block from falling satisfies. Okay, so what should be the acceleration of this cart so that the mass doesn't fall? Okay, the acceleration which prevents the block from falling satisfies which one of these? So let's check. So let's suppose there is a person who is standing over here. So tell me which frame is he in, the inertial or non-inertial? It is inertial. Very good, right? The person is steady. Okay, so person is steady or in constant velocity, moving with constant velocity. The frame of reference is inertial if he is moving with constant acceleration. No, any acceleration, right? If steady or constant velocity, inertial frame, and any acceleration means non-inertial frame. Okay, this one is inertial frame. This one is inertial frame. So this person observes what's happening and he writes down, he draws the free body diagram. okay, of this mass m. What are the forces acting on this one? One is the normal reaction, right? One is the normal reaction. Okay, let's draw this surface of cart 2. So one is the normal reaction which is acting in this direction, okay, and there is its weight acting downwards. So weight is equal to mg, and there is the frictional force between these two surfaces which is acting upwards, so Fs. If it is not falling down, means the normal reaction must be equal to what? Normal reaction must be equal to what did I say? If it is not falling down, means its weight is totally supported by what? The friction. Okay, it doesn't fall down, so friction is enough to prevent it sliding. Okay, it's sliding down from this plane, right? So friction must be greater than or equal to what? Mg. And you know what is the friction? So friction is equal to mu s multiplied by normal reaction. So it is mu s multiplied by normal reaction. This is greater than or equal to its weight. And then there is the normal reaction due to the cart. And what's happening to this block? It is moving along with the cart. So that means it is accelerating. And who is providing that acceleration? So which is the force in direction of acceleration? It's the normal reaction. What you can say is normal reaction provides normal reaction. Okay, so this person will say, oh, this block is accelerating in this direction and normal reaction is acting like this. So which is the force that results into the acceleration, which causes the acceleration of the block? It is the normal reaction, and therefore normal reaction is just equal to that mass multiplied by its acceleration. Acceleration is alpha, right? So you just put that over here, so you get mu s multiplied by m times alpha is greater than or equal to m times g. Okay, and then mm gets cancelled out, and you have alpha is greater than or equal to g divided by mu s, because mm is cancelled out. Okay, so this is the answer. Alpha is greater than or equal to g divided by mu s. So that is option C. Okay, this thing is clear, everyone? Yes, no? Right. So this is inertial frame of reference approach. Now we'll see the same problem in non-inertial frame. Non-inertial frame. Okay. So now suppose there is this part, it is made of glass, and there is a person standing or sitting inside this cart. Okay, and he sees that there is this block. Okay, there is a block. Okay, and it's not moving at all. Okay, it's not falling down, right? And somehow he knows that there is no adhesive connected over here. I mean, it's not stuck with this wall by means of an adhesive. Okay, that's the assumption, right? Okay, so then what he will do is he will also draw free body diagram. Okay, but then he is in non-inertial frame of reference. So since he is in non-inertial frame of reference, so he feels an acceleration in this direction, right? So he feels a pseudo force in opposite direction. So that's why he will say the mass of this block is m. So there must be a force acting on this block in the opposite direction, right? So for this person, the block is steady, means he knows that there is normal reaction which is acting in this direction, But then if there was normal reaction, then the block wouldn't be steady. Okay, if there was only one force acting in this direction, the block wouldn't be steady, right? So for him, the block is steady, right? For himself, he is steady, the other world is moving in backwards direction with some acceleration alpha. He is steady, the block is also steady because block is over here only. Okay, it's not sliding down, it's not moving up, right? So he sees that block and for him it is steady. This thing is clear? Yes, no? The block is always moving along with him, right? So therefore he says that there is normal reaction. Definitely there is a normal reaction which is acting in this direction. So now since the block seems to be steady, there must be a force acting in opposite direction. Okay, and how much is that force? So that force is equal to the pseudo force. Sorry, it is pseudo force Fp. And what is pseudo force? Okay, so since the block seems to be steady for this person, okay, since block seems to be steady for non-inertial observer, since block appears steady for non-inertial observer, you can say that normal reaction is just equal to the pseudo force, okay, and that is just equal to what? Mass times alpha. So for him, the world is accelerating in this direction, okay, and they are steady, right? So what is the pseudo force? Pseudo force is just mass into acceleration. The normal reaction is mass multiplied by alpha. So we know that the pseudo force, it appears to be acting in the opposite direction of acceleration, and what's the magnitude of that? Just mass into acceleration, okay. And then it's very simple. So he says, okay, so now it seems to be balanced, so normal reaction is in this direction, and he found the magnitude of normal reaction, okay, it's m times alpha, by a completely different argument as that of compared to what? This observer. So he found that n is equal to m times alpha, and then you have Fs must be equal to what? Mg, because it's not falling down, okay, if it is not stuck with the wall by some adhesive, okay. So then you have Fs is equal to what? M multiplied by G, okay, and that is mu s into normal reaction. So Fs must be greater than or equal to M multiplied by G, okay. So Fs is mu s multiplied by normal reaction, it's greater than or equal to mg. If it is not falling down, then it's equal to mg only, right? Okay, so n is equal to what? M times alpha, that is greater than or equal to mg. Mm gets cancelled and you get mu s is g by, sorry, alpha is g by mu s. You wanted alpha, no? So alpha is greater than or equal to g divided by mu s. So that's the answer, right? So the same answer you can find out using completely different argument. So this thing is clear, how to use inertial and non-inertial. Everyone? Okay, let's see another problem. A block of mass m is placed on a smooth inclined wedge. So this is a wedge and a block of mass m is placed over that. ABC of inclination theta. So theta is the inclination, this is theta, shown in the figure, as shown in the figure. The wedge is given an acceleration a towards the right, okay. The relation between a and theta, so acceleration is a and theta, for the block to remain stationary on the wedge is, this is the question, okay. The block remains stationary is given, and then what should be a? What is the acceleration? This is the question. So again, let's draw free body diagram. of this mass. So this mass is m, mass is m, now see, the system is accelerating in this direction, whole system is accelerating in this direction, okay, and acceleration is a. So now once again let's consider an inertial observer who is here and he watches that system, okay, inertial observer watches the system. So for him the system is accelerating in this direction, the block is also accelerating in the same direction. What are the forces acting on the block? So there is one normal reaction acting like this. This is the normal reaction, and there is weight which is acting like this. Okay, mass is m, this is g, and this angle is theta. So then what will this observer do? So he knows that he must resolve the forces in the direction of motion and perpendiculars to direction of motion, right? Okay, he needs to resolve the forces perpendiculars to direction of motion and in the direction of motion. Why? To check for the equilibrium. Okay, so then resolve the normal reaction in along the two components. So what will be those two components? So if this angle is theta, this angle is also equal to theta. This angle will be 90 minus theta, right? This angle will be 90 minus theta. Then what would be this angle? So this angle is again theta. Okay, so once again this angle is theta, so this is going to be equal to theta. This is equal to theta. What is this angle? This one is 90 minus theta. Oh, what did I say? This angle is theta, so this angle is also going to be equal to theta, right? This one and this one, right? Two parallel lines and the intercept. So this angle is theta, so this is also equal to theta. This is theta. This one is going to be equal to 90 minus theta because this total angle is 90 degrees. And if this is 90 minus theta, then this angle is going to be equal to theta. So this angle is theta. And now let's resolve n. So component through the angle is cos component, component away from angle is sine component, right? So resolve n along two components. So you get this component which is n sine theta, and you get this component which is what? N cos theta. Okay, and now once he resolves the forces, it's very clear to him that what must this vertical component do. So the vertical component of normal reaction n cos theta, it just supports the weight. Okay, it balances the weight. So n cos theta is equal to mg. He writes down this. Then what does the horizontal component do? So n sine theta, there is only one force in the horizontal direction, and it must provide this acceleration. Okay, it must cause this acceleration because he sees that the system is accelerating, right? So for this block, which force causes the acceleration? It is this n sine theta, right? So n sine theta must be equal to m times a, right? And then we wanted to find out a, so this is equation 1, this is equation 2. So what we can do is we can just divide equation 2 by 1, right? Equation 2 divided by 1. What do we get on left hand side? It's n sine theta, n sine theta divided by n cos theta, and that's equal to m times a divided by m times g. Gets cancelled out, then nn gets cancelled out. So sine theta by cos theta is tan theta. Tan theta is equal to a divided by g, and therefore a is just equal to g tan theta. So this is the answer, option D. Okay, this thing is clear. Okay, so once again, which way was this one? This was the inertial way. right? So once again, let's solve this problems, the same problem using non-inertial frame. So it's the same one, yeah, same one. So let's solve this one using non-inertial frame. So there is some person who is also sitting over here, okay, on the wedge. The person is sitting on the wedge, and he sees that he is steady, he is not sliding down. The block is also steady, block is also not sliding down, okay. He is steady and he sees that the wedge is accelerating in this direction. So there must be a force on him also in this direction. That's the pseudo force, okay. If the wedge accelerates like this, imagine it's like when you are sitting in a bus and bus accelerates in forward direction, you feel a force in backwards direction. Just like that, you will also feel force in backwards direction, okay. The magnitude of that is his mass multiplied by acceleration, okay. Acceleration is a, right? So m times a, and then he reasons that there must be a force on m also, this mass also, okay, which is in opposite direction of the acceleration, okay. But for him, he is not accelerating, block is not accelerating. For him, there is one component of normal reaction which is acting in this direction. So there must be another force acting on the mass also, which is acting in opposite direction. That is the pseudo force, right? So for him, the world is accelerating in backwards direction. This thing is clear? Yes, no? Okay. So the only difference is there. See, this normal reaction he will also see, then mg he will also see, and he will also resolve the normal reaction in two components. But for him, the block is steady, block is not moving. So if normal reaction, this component of normal reaction is towards right, so there must be one force towards left, okay. There must be a force towards left which balances that component of normal reaction. So what is that force? It's the pseudo force, okay. So in non-inertial frame of reference also, weight is balanced by the vertical component of normal reaction. So n cos theta is equal to mg, and n sin theta is equal to what? In magnitude, it is equal to what? The pseudo force Fp. And what is the pseudo force? So we know the magnitude of pseudo force is equal to what? Mass multiplied by acceleration of the system, m times a, okay. So then it comes out to be same, right? Next steps are same. There is only one difference, that is the difference in thinking, okay. This thing is clear? Yes, no? Right? So then you can just divide this thing by this thing, okay. Equation 1, this is equation 2, right? 2 by 1 will give you the same thing. So tan theta is equal to a by g, and therefore a is equal to g tan theta. So what's the difference between inertial frame and non-inertial frame of reference? The only difference is the observer observes from outside, okay. Observer is steady, right, or he is in uniform motion, so there is no acceleration. Then the forces that he applies are only the real forces, and he sees that this acceleration is cause of the real forces, okay. He sees that the system is accelerating, or this mass is accelerating, so it must result from what? It must result from some real force. And what's that real force? In this case, it is the horizontal component of normal reaction. And in case of non-inertial frame of reference, so he sees that there is horizontal component of normal reaction acting on this block, but for him, he is steady, the wedge is steady, the block is steady, everything is steady, right? The remaining world is moving in backwards direction for him, okay. So there is the force which is keeping it steady in reference to him, and that's why he says that there is a force acting in opposite direction, okay, to that of his own acceleration. He doesn't know that he is accelerating, right? This thing is clear? Yes, no? So that force balances the horizontal component of normal reaction. Okay, so the difference between inertial and non-inertial. Good. So now, will you be able to solve problems based upon inertial and non-inertial frame of reference? So actually you need to stick to one. It's not like you need to master inertial frame also, non-inertial frame also. Okay, so if you can think in terms of inertial, stick to inertial. Okay, and I don't even find a difference. I mean, see, in this case and also in this case, I required same time. Okay, here we did it little bit quick because we already knew the next steps, right? So personally, I don't see a difference between inertial and non-inertial. The time taken to solve the problem is also same. Okay, right? And these kind of problems are repeated also. So if you do them repeatedly again and again, so you will know that A is equal to G tan theta, right? So if they ask what is A is just equal to G tan theta, then there is no need to spend time in the exam. Okay, in practicing, yes, you need to spend time, but not in the exam, right? Let's see next one. A block of mass m is placed on a smooth wedge of inclination theta. The whole system is accelerated horizontally so that the block does not slip on the wedge. The force exerted by wedge on the block will be, okay, tell me, force exerted by wedge, that means they are asking about the normal reaction. So it's the same thing. They have not given the diagram in this one. In this case, the diagram would be same, and then this is the wedge. Okay, this is the block. There would be this normal reaction acting on the block, right? Then it's very simple, right? So we know that what we had just found, no? So A is equal to G tan theta. Okay, force exerted by wedge on the block will be, force exerted by wedge on the block will be, okay. So here you can just say that n cos theta is equal to mg, right? N cos theta is equal to mg, and therefore what will be n? It is just mg divided by cos theta. That's it. You want force exerted by wedge on the block, so that is the normal reaction. What is normal reaction? It is just this weight divided by cos theta. This thing is clear. Everyone, Indusha, is it clear?
Yes, sir.
Okay, good. So that's why the answer is option D. Okay, it's the same as that of last problem, but they asked for the different thing here. They asked for the normal reaction. Okay, let's see next one. Now you will tell me this. A mass m is placed on very smooth wedge resting on surface without friction. Once the mass is released, the acceleration to be given to the wedge so that m remains at rest when m remains at rest is A. Where? So what is A? This is the question. A is applied to left, and A is equal to G tan theta. A is applied to right and A is equal to G tan theta. A is applied to left and A is equal to G sin theta. A is applied to left and A is equal to G cos theta. Which one is correct? Tell me. Everyone? Yeah, it is option A, right? So in this case, you can see the inclination of plane was like this. Okay, so when you give some acceleration towards right, then it provides for the normal reaction. Okay, so imagine if you provide the acceleration in opposite direction, what will happen? It was already slipping. Okay, the mass was going to slip and you're taking the wedge away. It's like that. so it will slip faster. This thing is clear, right? So the acceleration cannot be towards right. So if you are giving acceleration towards right, that means it was already moving down and you are moving the wedge away, okay, away from it, right? So it will slide down even faster. Okay, can you imagine that? Yes, no? Right. So answer is what? It has to be towards left to provide for the necessary normal reaction. Okay. If you are giving acceleration towards right, means you are decreasing the normal reaction. Okay. If you are giving acceleration towards left, that means you are supporting it. You are giving some normal reaction. If you are giving acceleration in opposite direction, that means you are removing the normal reaction, decreasing the normal reaction. Okay. All right. So A is applied to left and A is equal to G tan theta. That's the answer, right? Okay, let's see next one. A heavy uniform chain lies on a horizontal top of table. If the coefficient of friction between the chain and the table is 0.25, the minimum percentage of length of the chain that can hang over the one edge of the table is. This is the question. Coefficient of friction is 0.25. Okay, tell me. So this is a table and you have a chain. The chain is like this. No. So this is the chain. Okay, and it's given that the maximum percentage of length of the chain that can hang over one edge. That's why I have drawn this maximum percentage that can hang over one edge. So now what will happen? So see, because of this hanging part of the chain, there will be a force downwards that is equal to, let's say, m times g, or let's suppose mass of this part is m1, mass of this part is m2, so the weight is m2 times g. Okay, weight of the hanging chain is m2 times g, right? So this part will pull on this part, right? Or you can think of this like this: there will be some tension in the chain, it will act upwards for this part. For this part it will act towards right, and then you will have the frictional force which will act in opposite direction. Okay, so there is frictional force which acts in the opposite direction, which avoids falling of this chain or further sliding of the chain, right? So you can think of tension, adjust mode of transfer. So this friction and the static friction and this weight must be balanced, because weight is greater, it will slide in this direction. Okay, static friction cannot be greater. Okay, we know that the frictional force is the force which balances itself against what? The externally applied force. Frictional force is the force which balances itself against the externally applied force. It tries to match itself. Okay, but there is the limit up to which it can act, right? And what's that limit? It's μs multiplied by normal reaction. This thing is clear? Yes, no? Okay, it is clear, right? So then now friction and this weight must be balanced, right? The friction and weight must be balanced so that the chain doesn't slide. Okay, so you can say Fs must be greater than or equal to mg, okay, or m2g. And what is Fs? It is μs multiplied by normal reaction. It's greater than or equal to m2g. What is normal reaction? So this mass is m1, its weight would be m1 times g. Therefore normal reaction is just equal to what? m1 times g. We can put that. So mu s times m1 into g greater than or equal to m2 times g. G cancelled. So you have mu s times m1 greater than or equal to m2. Okay. And then how to find out the percentage? So it's very simple. So what we can do is, here the mass of this chain is directly proportional to length. If thickness is equal, mass of the chain is directly proportional to length. So I can say total mass is m and total length, m is suppose the mass and L is the total length, right? So m is just equal to this mass plus this mass. Total length is this length plus this length. So I can say that m1 is directly proportional to L1, this length, and m2 is directly proportional to this length. So m2 is proportional to length L2. So you can say m1 is some k times L1. This is some k times L1, and that's greater than or equal to m2, which is k times L2. And then you can cancel out k, take L1 on that side. So mu s is equal to, it's greater than or equal to L2 by L1, right? How much is mu s? Mu s is 0.25. So 0.25 is greater than or equal to L2 by L1. Okay, or that means that's 1 by 4. No, 1 by 4 is greater than or equal to L2 by L1. So 4 times L1 is greater than or equal to L2, or at the best 4 times L1 is equal to, or did I do opposite thing? Yeah, sorry, this is 1 by 4. It's equal to, let's say it's equal to L2 by L1. So you have L1 is equal to 4 times L2, right? Yes, no. And what is L? L is equal to L1 plus L2. Okay, that means it is L2 is 4 times L1. Okay, sorry, L1 is 4 times L2. So it is 4 times L2 plus L2 means 5 times L2. So therefore what is L2 by L? It's equal to 1 by 5. That means how many percent? So L2 by L1, sorry, L2 by L times 100 is equal to what? 1 by 5 multiplied by 100. So that is 20%. Okay, is this thing clear? Yes, no? Everyone? Right. So the answer is 20%, option A. Okay, good. So then these are the sort of problems that can be asked based upon laws of motion. I mean, based on the free body diagrams. Okay.